Hello, how's it going out there in math land? Just want to show you a couple of things about graphing functions. Let's take a look at the course home here, and I have some suggestions. One thing worth checking out is the Wabbit calculator. I'll do another recording about that later. My favorite calculator in general is a program called GeoGebra. Now, GeoGebra will run on any computer that has Java, which is most computers these days. And you can run it in a browser, or if you're doing Windows or Mac, you can run it on there. And let's see, I want the web start. That's the one I recommend down here. The others, Windows, that runs it off your desktop. So I'm in Chrome here, so I'm going to tell Chrome to keep it and open it. Depending on your browser, it may just open immediately. As long as your Java is up to date, everything should work pretty good. So it downloads some initialization files. Sometimes that takes a little longer depending on your connection. The nice thing about the web start is you don't have to worry about upgrading GeoGebra when they come out with a slightly new version. Web start's always up to date. And almost there. So now Java's running the file. Okay, so we have this basic view here. It's what's called the algebra panel. The PC one looks pretty similar. I don't think I need my perspectives right now. Oops. There we go. On the graph, sometimes I like to right-click with my mouse and see the grid. That makes me feel better, like I have a piece of graph paper. Now, a function is where you have input and output. So I'm going to open up my spreadsheet to kind of demonstrate that. First, I'm going to type a function right here, 2x plus 1. So this is the input bar. If I just type an expression like that, GeoGebra assumes I meant y equals, and it automatically calls y f of x. Now y equals f of x means y is a function of x, which means y depends on x. Right? X is independent, y is dependent. Here I can find y values by doubling the x value and then adding 1. So if my first x value is 1, doubling 1 I get 2, adding 1 I get 3, so I have the point 1, 3. Similarly, if I were to plug x equals 2 into my expression here, 2 times 2 is 4, plus 1 is 5, so I should have the point 2, 5. Right? So hopefully you graphed lines a while back. And so GeoGebra is pretty nice working with that. Other nice thing about GeoGebra is if I want to know, for example, where does this function hit either the y-axis or the x-axis, I can switch from the regular point tool with this down arrow to the intersect two objects tool, and then I can point at the line and click, and point at the axis and click. And GeoGebra will tell me that point A, the intersection, is the point -1/2, 0. Similarly, if I wasn't sure if that was the point 0, 1, again the intersection tool is highlighted, click, click, GeoGebra says, yeah, that is the point 0, 1. So it finds intercepts really easy, even for more complicated functions. Like later we're going to play with a function like, let's see, x squared minus 2x, and let's go plus 1. Oh, it's not the one I wanted. And if I want to edit a function, I just double click, and that plus 1 I want to be a -1, enter, and GeoGebra will redo it for me. I can say I want to hide that function, I just click that little bubble. Once you get used to GeoGebra, it's pretty nice. Or I can decide I might want to delete something, so I could right click on something and choose delete. So here I want to find the intercepts for the x-axis and the intercept for the y-axis. I just go to my cute little tool here, click, click, and GeoGebra thinks for a minute. Did I miss something? I must have missed. Let me try that again. Intersect tool, click. Oh, there we go. I must have missed when I clicked. And now here the problem is it gives me approximations. We'll learn techniques for getting exact answers. These guys involve square roots, so you might remember completing the square. Sometimes you need more decimal places. Just go to options, rounding. Maybe I want 5 or 10 or 15 decimal places. I'll go with 5. Come on, GeoGebra. Usually works so well. Weird. I don't know why it's not doing that. Options, rounding, it seems to be locked. Well, it usually behaves so nice. Figures when I'm recording, it doesn't. Oh well. Anyway, it's a nice tool for playing around here. Domain of a function is something you might be struggling with right now. Domain means what x values you're allowed to plug in and get answers for. Well, I can double any number I want. I can add 1. So the domain of my original function, f of x, should be all real numbers. Another way to see that is I can trace down or up and hit the x-axis from anywhere on this straight line. Domain of the set of x values you have to work with. Range, set of y values. So if I focus on this function, I would say from any point where do I get y values on the axis. And so here I can see there's definitely a point for y equals 3 here and here, 4.5 up here. But if I scroll down a little, y equals -3 has no points associated with it, so that's not part of the range of this function. Whatever the bottom point there is, I'm guessing it's -2. Well, we have a technique for finding that later in chapter 2. So I could say the range of this function would be from -2 up to infinity. Domain of this function, well, I believe it continues up and to the left, up and to the right forever, which means I could trace down and hit any x value I want. Even x equals 6, ultimately there's a point way up there for it somewhere. Domain looks like it's all real numbers. Double checking the equation, I can square any number I want. I can subtract and multiply any 2 numbers I want. So I can do this calculation to any numbers I want. So the domain, what I input, can be anything. Range is trickier. We have to look at graphs to get range, and sometimes we have to resort to technology to help us find minimum points or maximum points, and we'll get to that later. So again, GeoGebra is a really nifty program. I highly recommend you play around with it. It is my favorite graphing program. Another one I like is this one down here, the Desmos calculator. It's pretty cute. Let's open that up. Alright, so you get this pretty good keypad here. I'm going to type y equals 2x plus 1, and notice it starts graphing as I move along. I can move that keypad out of my way. I can always bring it back up later if I want. It automatically is showing me those cool points, intercepts that I want to know. I can add a new function here. Oops, how do I do that? Just click right there, okay. Y equals x. Now to get an exponent, Shift 6 has what's called the caret key, which gives you a superscript, squared, arrow to the right to get out of the exponent position. A lot of TI calculators work this way too. Minus 2x minus 1. Give me that function I had before. I can turn that function off temporarily just like in GeoGebra, or I can delete it. And notice it's giving me these nice points, x-intercept, x-intercept, y-intercept. It even gives me the minimum point. GeoGebra I have to do a little bit more work to find the minimum point. So this Desmos calculator is really nice for analyzing graphs and functions. You can click and drag and move it around. It'll redraw it. You can zoom out and zoom in, which is pretty neat. Create yourself an account and you can save stuff. So the Desmos calculator is wonderful too. Highly recommend it. Again, so what's my point? My point is you do need a graphing utility, but you don't have to go buy a $100 calculator. One of these online tools is excellent. That's it for now. Over and out. Do good math. I'll see you soon, online or in person. Bye-bye.